Good morning, my dear students. Welcome to the world of physics. So, the previous chapter we were discussing about heat. Heat was one of the forms of energy. Today we are going to discuss about new chapter. Our chapter name is sound. I hope that you have already studied something about sound in previous year. So we are just revising that one. Or in one way we can say that we are studying the same thing, we are repeating the same thing, little more enlarged version. Okay. So when we are discussing about sound, in daily life we are able to hear many sounds. Sometimes the sound may be produced by the non-living things, sometimes the sound may be produced by the living things. Even when we are discussing about sound, when we are discussing about the word sound, every day sound is the medium through which we are transferring the messages or how we are going to communicate. One of the main medium or one of the easiest method to communicate between me and you, or the communicate between human beings, or the communication between the animals, etc. is used by the sound. And you are able to hear or you are able to detect your parents or your brothers or sisters sound, even though they are talking in a phone or when they are talking without seeing them, you are able to recognize. So some conditions are there where we can detect the sounds of our friends. Maybe after 1 year or 2 years also, if you hear the sound of your friend, you will be able to detect. So in this chapter, we are going to discuss about mainly 3 characteristics of sound. The first characteristic is intensity or loudness of sound, and the second one is pitch of the sound, and the final one, the third characteristic is quality or timbre. Then following with that we will discuss about what is the difference between music and noise. Then we will discuss something about some musical instruments. This is about this chapter. So today we are going to discuss about what is sound, what is rarefaction and what is compression, what are the general terms when we are discussing about sound as a wave, and first characteristics, that is loudness or intensity. So these are the 3 main points that we are going to discuss today. So what is sound? Sound is a form of energy. All we know that sound is a form of energy which causes the sensation of hearing, or which is producing the sensation of hearing on us. And we have discussed that sound is traveling in the form of a wave. Sound is traveling in the form of a wave. What is specialty of a wave? That means when the wave or a disturbance is passing, the matter is going to just vibrate and come back to the same point. The matter do not have any change in the position. So sound is traveling in the form of a wave. And in chapter 2, motion, or the previous chapters we have studied about vibrations. Sound is produced by the vibrating bodies. What is vibration? The to and fro motion of an object is called a vibration. So here, as I said that sound is traveling in a wave, we can say that sound is traveling in the form of a longitudinal wave. Sound is traveling in the form of a longitudinal wave. What is longitudinal wave? Suppose when I speak, when you are sitting in my class, you will be able to hear my sound. How you are able to hear? I am producing my sound from my throat or vocal cords, and I am sending through the mouth this to the air. And in between you and me, there are some air molecules are there. Right now, air molecules are there. So we can say that this is the arrangement of molecules of air. When from my mouth, the vibration is given to the first layer. Okay, and this first layer will start vibrating. Already when we have discussed about the states of matter, we have studied about the solid state. There we have seen that the molecules are not able to change their position, but they are able to vibrate. So this air molecule, these molecules are going to vibrate. So when they are vibrating, what happens? They will come closer. They will come closer. For example, this was air. They will be just shifted here. So these layers will become closer. And this vibration will pass to the next one. When it is passed to the third one, these two layers will become closer. This will come back to the back position. This is called this is how the sound is transferring. And when these vibrations are reaching to our ear, your eardrum is going to start vibrating, and this vibration will cause the sensation of hearing in human being. Clear now? So it is clear that when we are sending or when we are producing sound, when we are sending into the sound into a medium, what will happen? The molecules will start vibrating. As a result of this vibration, the sound energy is transferred from one point to the another point. See, here there is a tuning fork is there. Tuning fork is a U-shaped made by a steel material, and when we are striking with a rubber hammer, the tuning fork, these two ends will start vibrating. This vibration is given to the air. So this air molecules will start vibrating, and some part of the air molecule will come closer. When they are coming closer, then they will transfer the energy and they will go back to the main position. And the second layer is going to get the energy. The second layer is going to come closer to the third layer. Again, they will transfer the energy. So, like this, from the layer to layer, the energy, sound wave is going to be, or the disturbance is going to be transferred. So, as a result, what will happen? Some amount of number of molecules will come closer, and that portion is called compression. That portion is called compression. And some molecules will be, that means once it is going, this disturbance is gone, they will relax. That is called rarefaction. Compression and rarefaction. These are the two things that we have to remember when sound is traveling in the form of a wave, which form longitudinal waveform. Now, what is longitudinal waveform? When I speak or when you are sitting in my class, you are able to hear my sound. As I said, that these vibrations are passed, and this molecule in between you and me, the air molecules are vibrating in the same direction of the sound. I am speaking from here, so the direction of sound of propagation is forward direction. This molecule also will be vibrating in the same direction. If the molecules of a wave is vibrating parallel to the direction of the wave, then we can say that they are longitudinal waveform. They are longitudinal waveform. Now, we are going to discuss about the terms related to sound wave. The terms related to sound wave. So, what are the terms related to sound wave? Last year already we have discussed, but we are able to mark, or as I said that sound is traveling in the form of wave. We are going to represent the wave. So, sound is produced by vibration. Vibration means the body is at a particular resting position, that is called the mean position. When we are striking, this body will start vibrating from the mean position to one side, coming back to the mean position, going to the next side, again coming back. This is called one complete vibration or one complete wave. So, we have taken pressure in the y-axis and the x-axis. We are taking the distance, and I am going to represent one wave. One wave means this is the mean point or zero. It is going to vibrate in the one side, going to the maximum, again coming back to the mean position, that is zero, going to the other side, to the maximum displacement, again coming back to the mean position. This is called one wave or one vibration. One wave or one vibration. Got it now? What is one wave? When the body vibrates, the body starts vibrating from its mean point to the one side, then coming back to the mean position, going to the other side maximum, then coming back to the mean position. This is called one complete wave. Then, as there are two things you can see, that crust and trough. Crust and trough. What is this crust and trough? Crust is the point of maximum compression, because this is what is compression and rarefaction. The point of maximum compression is called the crust. And what will be the trough? The point of maximum rarefaction is called the trough. The point of maximum compression is called the crest, and the point of maximum rarefaction is called the trough. Okay, and this crest and trough, already two terms you have new to you that you have learned. Now, what is one wave? One wave is the from the mean position and body vibrates one side to the maximum, coming back to the mean point, go to the next side maximum, coming back to the mean point. This is called a one wave. So in this graph, I have shown two waves. One is this is one, then again this is two. Two waves I have shown. Now, what is wavelength? What is wavelength? The distance between two consecutive compression or crest, or the distance between two consecutive rarefaction or trough is called wavelength. Okay, so we can say that wavelength can be, this is like two consecutive compression, thus this is called a wavelength. The distance from here to here is called a wavelength, or we can say like this, the distance from here to here is called a wavelength. Clear now? This is called a wavelength. The distance between two consecutive compression or two consecutive rarefaction is called a wavelength of the wave. And this wavelength is represented by the letter lambda. The letter lambda. This is the letter lambda. Now, next one. What is oscillation? What is one oscillation? What do you mean by one oscillation? One complete front and back motion. That means from the mean position, it is going to travel to the one side extreme position, coming back to the mean position, and going to the extreme, the other side, coming back to the mean position. So one complete front and back motion is called one oscillation. Is called one oscillation. Now, next one, time period. Next one is the time period. Time period is time taken to complete one complete vibration. What is time period? Time taken to complete one complete vibration or one complete oscillation. One complete vibration or one complete oscillation. That is called a time period. Okay? Then again, we are going to discuss about the last term, general term, that is frequency. That is a frequency. What is frequency? The number of vibrations or the number of waves produced in 1 second is called frequency. What is frequency? The number of complete vibrations or the number of complete oscillations produced in 1 second is called frequency. These are the general terms for sound wave. When we are representing sound as a wave. So once again, here we have discussed about rarefaction and compression, and the terms related to the sound wave. We are here able to represent sound in the form of a wave. We are traveling in the form of a longitudinal wave. Then first one we have studied about what is one wave. One wave is the displacement from the one complete vibration is the displacement from the mean position to the other side maximum, coming back to the mean position, going to the next side maximum, coming back to the mean position. This is called a one complete wave. So, two waves are there on the graph. Now, wavelength, crest means what? The maximum compression is called crest and the maximum rarefaction is called trough. The distance between two consecutive crests or the two consecutive trough is called wavelength, and wavelength is denoted by lambda. Then next one, oscillation. What is oscillation? One complete oscillation or vibration means from the mean position going to the one side extreme, coming back to the mean position, going to the other side extreme, coming back to the mean position. This is called one complete oscillation. Then again, the time period, time taken to complete one vibration is called time period. And frequency, number of complete oscillations produced in 1 second is called frequency. Then one more term is there, amplitude. One more term is there, amplitude. What is amplitude? The maximum displacement from the mean position. The maximum displacement from the mean position is called amplitude. So amplitude, this is the maximum displacement in crust for the compression, and this is the maximum displacement in the rarefaction. These both are called, this one will be same, they are called amplitude. They are called amplitude. The maximum displacement of a wave from its mean point is called amplitude. Okay, now we are going to discuss about the first characteristics of sound: loudness or intensity. Loudness or intensity. What is loudness or intensity? Loudness is a characteristic of sound which is going to distinguish between a feeble sound or a small sound to a loud one of the same frequency. Loud one of the same frequency. What is the loudness or intensity? Loudness or intensity can be defined as it is the difference or it is the characteristic of a sound which distinguishes between a feeble sound to a loud sound of the same frequency. What do you mean by same frequency? Both the cases, the number of waves will be same. The number of waves will be same. For example, if I draw two diagrams here, maybe this one wave, two wave. This is also, this is one wave, this is second wave. Two waves are there. What is the difference there? The displacement or the amplitude. Here the amplitude is higher, here the amplitude is less. That means this is the displacement of what amplitude, and this is the first case, the first graph, the amplitude is maximum, the second case, the amplitude is less. So when the amplitude is more, then what will happen? The loudness or intensity will be maximum. And when the amplitude is less, same, the loudness or intensity will be less. So in daily life we used to hear so many sounds. For example, you can hear the sound of a tabla as well as you are able to hear the sound of a drum. Which one will be bigger? That means the waves produced by a tabla will be having less amplitude, and the waves produced by the drum will be having big amplitude. That means displacement. Then again, the wave which is having more amplitude will have more energy. Is it not? Vibration means the wave which is, or the body which is having more energy will be shifting more to one side, coming back, shifting to the other side also more, coming back. The molecule which is having less energy, or the body which is having less energy will be shifting less, coming back, shifting to the other direction less, coming back. So we can say that the intensity or the loudness of the wave is higher, means the energy of the wave also will be high. So loudness depending upon first one, amplitude. If the amplitude is maximum, then the loudness also will be maximum. And when the amplitude is minimum, loudness is also going to be minimum. Then next one, energy. If the wave is having more energy, more loudness. The wave is having less energy, less loudness. So when we are speaking very generally normal talking, then we are having loudness less. But we are able to talk very loud. At that time, our energy is very high, or the amplitude vibrating object will be having maximum displacement, or the amplitude is more. Then three more factors are there. Two more factors. What is the area, which is controlling the loudness? The area of the vibrating body. If the area increases, the loudness also will be increases. You might have seen during the assembly, two drums we are having. One is smaller and the other one is bigger. The smaller is going to produce feeble sound compared with the bigger one. Or the first example, as I said, that we are going to compare with a tabla and a drum. Tabla is having vibrating body. The area of vibrating surface is very less compared with the drum. So tabla is having feeble sound, and the drum is going to have very loud sound. Also, characteristic of sound which distinguishes between a feeble sound and a loud sound is known as what? Loudness or intensity of sound. Then again, next one, increases in decreasing the distance. That means loudness increases when the distance is less. For example, when the program is going on, if you sit very near to the speaker, you will be able to hear very loud sound. If you are back of the stage or back of that tent, then what will happen? The loudness what you hear is very less. but the frequency of the verb sound produced will remain same. So this is about today. Then one more thing is there. The some factors on which loudness of sound depend is atmospheric temperature, pressure, velocity of wind, and the amount of moisture present in the air. These factors also control. So if the wind is opposite, what will happen? The sound wave cannot move forward. So the energy loudness will be less. Temperature increases means the molecules are going to get more energy, so amplitude will be more, so the loudness will be more. Then next one. There is an activity given on your page textbook, page number 93. That means we have to just prove that the loudness and the amplitude is having a relation. So what we are going to take a ski glass and on a front we are going to just put a thermocol board just touching on the glass. Okay, then what you will do, using a spoon, you are going to strike it very gently. If you strike gently, this will be having a small amplitude. That means this is going to a small distance and coming back. If you strike the spoon very hard, you will produce a big sound. That means loud sound. Maybe at the same time, the displacement of the thermocol board also will be more. So this can be represented as an amplitude. So when we are producing less sound, the amplitude also is going to be less, and when we are producing loud sound, the amplitude is also going to be higher. Okay, so this is about today's topic. So whatever things we have discussed, what is sound? Sound is a form of energy which causes the sensation of hearing, and we have seen about the rarefaction and compression. Sound is traveling in a wave, in the form of a wave. So when this sound wave or disturbance is given to the air, or the molecules will come closer. When these molecules are coming closer, we can say that it is called compressing. And when the wave disturbance is passed, they will go back to the mean position or the normal position. That is called rarefaction. Then we have discussed about some general terms that we are able to represent sound in the form of a wave. So one complete wave means it is starting from the mean point, going to the one side maximum, coming back to the mean point, going to the other side maximum, coming back to the mean point. Then the number of then we have seen about what is oscillation. One complete to one form motion is called one oscillation. Then we have seen about what is the amplitude? The maximum displacement from the mean position is called amplitude. Then we have seen what is thrust and trough. Thrust is the maximum of compression, and trough is the maximum of rarefaction. Then we have seen about time period. Time taken to complete one wave is called time period. It is represented by capital T. Then we have seen about frequency. The number of complete vibrations produced in 1 second is called frequency. Then we have discussed about the loudness or intensity, the characteristics of the sound, which distinguishes between a feeble sound to a loud sound of the same frequency is called loudness or intensity. And there is a relation between frequency and time period. Frequency is represented by a small letter f. Small letter f is equal to 1 divided by t. Okay. Now there is a homework on page number 92 on your textbook. There is a diagram is given and the terms related to the sound wave. So you have to take an A4 size sheet paper and you have to draw and mark the parts, and some explanations are there that you have to write on the A4 size sheet. That means the column which is given page number 92, you have to do it on an A4 size sheet. Thank you.